Chapter 9 of Curiosities of the Sky. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Greg Bell. Curiosities of the Sky by Garrett, Serviss. Chapter 9. Marvels of the Aurora. One of the most vivid recollections of my early boyhood is that of seeing my father return hastily into the house one evening and call out to the family, "Come outside and look at the sky." Ours was a country house, situated on a commanding site, and as well we all emerged from the doorway, we were dumbfounded to see the heavens filled with pale flames, which ran licking and quivering over the stars. Instantly there sprang into my terrified mind the recollection of an awful description of the Day of Judgment, which I had heard with much perturbation of spirit in the Dutch Reformed Church from the lips of a tall, dark-brown, dreadfully in earnest preacher of the old-fashioned type. My heart literally sank at the sight of the spectacle, for it recalled the preacher's very words. It was just as he said it would be, and it needed to be assured bearing of my elders finally to convince me that day of wrath, O dreadful day, when heaven and earth shall pass away, as David and Sybil say, had not actually come upon us. And even the older members of the household were not untouched with misgivings when menacing spots of crimson appeared, breaking out now here, now there, in the shuddering sky. Toward the north, the spectacle was appalling. A huge arch spanned an unnaturally dark segment resting on the horizon, and above this arch sprang up beams and streamers in a state of incessant agitation, sometimes shooting up to the zenith with a velocity that took one's breath, and sometimes suddenly falling into long ranks and marching, like an endless phalanx of fiery specters, and moving, as I remember, always from east to west. The absolute silence with which these mysterious evolutions were performed, and the quavering reflections which were thrown upon the ground, increased the awfulness of the exhibition. Occasionally, enormous curtains of lambent flame rolled and unrolled with majestic motion, or were shaken to and fro as if by a mighty noiseless wind. At times, too, a sudden billowing rush would be made toward the zenith, and for a minute the sky overhead would glow so brightly that the stars seemed to have been consumed. The spectacle continued with varying intensity for hours. This exhibition occurred in central New York, a latitude in which the aurora borealis is seldom seen with so much splendor. I remember another similar one seen from the city of New York in November 1882. On this last occasion some observers saw a great upright beam of light, which majestically moved across the heavens, stalking like an apparition in the mist from auroral pageant, of whose general movements it seemed to be independent, maintaining always its upright posture, and following a magnetic parallel from east to west. This mysterious beam was seen by no less than 26 observers in different parts of the country, and a comparison of their observations led to a curious calculation indicating that the apparition was about 130 miles tall, and moved at the speed of 10 miles per second. But as everybody knows, it is in the Arctic regions that the aurora, or the northern lights, can best be seen. There, in the long polar night, when for months together the sun does not rise, the strange coruscations in the sky often afford a kind of special daylight in unison with the weird scenery of the world of ice. The pages in the narratives of Arctic exploration that are devoted to descriptions of the wonderful effects of the northern lights are second to none that man has ever penned in their fascination. The lights, as I have already intimated, display astonishing colors, particularly shades of red and green, as they flit from place to place in the sky. The discovery that the magnetic needle is affected by the aurora, quivering and darting about in a state of extraordinary excitement when the lights are playing in the sky, only added to the mystery of the phenomenon until its electromagnetic nature had been established. This became evident as soon as it was known that the focus of the displays was the magnetic pole, and when the far south was visited, the aurora australis was found, having its center at the south magnetic pole. Then, if not before, it was clear that the earth was a great globular magnet, having its poles of opposite magnetism, and that the auroral lights, whatever their precise cause may be, were manifestations of the magnetic activity of our planet. After the invention of magnetic telegraphy, it was found that whenever a great aurora occurred, the telegraph lines were interrupted in their operation, and the ocean cables ceased to work. Such a phenomenon is called a magnetic storm. The interest excited by the aurora in scientific circles was greatly stimulated when, in the last half of the 19th century, it was discovered that a phenomenon intimately associated with disturbances on the sun. The ancient Zurich chronicles, extending from the year 1000 to the year 1800, in which both sunspots visible to the naked eye and great displays of auroral lights were recorded, first set Rudolf Wolff on the track of this discovery. The first notable proof of this suspected connection was furnished with dramatic emphasis by an occurrence which happened on September 1, 1859. Near noon on that day, two intensely brilliant points suddenly broke out in a group of sunspots, which were under observation by Mr. R.C. Carrington at his observatory at Red Hill, England. The points remained visible for not more than 5 minutes, during which interval they moved 35,000 miles across the solar disk. Mr. R. Hodgson happened to see the same phenomenon at his observatory at Highgate, and thus all possibility of deception was removed. But neither of the startled observers could have anticipated what was to follow, and indeed, it was an occurrence which has never been precisely duplicated. I quote the eloquent account given by Mr. Kirk in his History of Astronomy during the 19th century. This unique phenomenon seemed as if specifically designed to accentuate the interference of a sympathetic relation between the Earth and the Sun. From August 28th to September 4th, 1859, a magnetic storm of unparalleled intensity, extent, and duration was in progress over the entire globe. Telegraphic communication was everywhere interrupted, except, indeed, that it was in some cases found practicable to work the lines without batteries, by the agency of the earth currents alone. Sparks issued from the wires, gorgeous auroras draped the skies in solemn crimson over both hemispheres, and even in the tropics the magnetic needle lost all trace of continuity in its movements, and darted to and fro as if stricken with inexplicable panic. The coincidence was even closer. At the very instant of the solar outburst witnessed by Carrington and Hodgson, the photographic apparatus at Kew registered a marked disturbance of all three magnetic elements, while shortly after the ensuing midnight the electric agitation culminated, thrilling the whole earth with subtle variations, and lighting up the atmosphere from pole to pole with coruscating splendors, which perhaps dimly recall the times when our ancient planet itself shone as a star. If this amazing occurrence stood alone, as I have already said it has never been exactly duplicated, doubt might be felt concerning some of the interferences drawn from it. But in varying forms it has been repeated many times, so now hardly anyone questions the reliability of the assumed connection between solar outbursts and magnetic storms accompanied by auroral displays on the earth. It is true that the late Lord Kelvin raised difficulties in the way of the hypothesis of a direct magnetic action of the sun upon the earth, because it seemed to him that an inadmissible quantity of energy was demanded to account for such action. But no calculation like that which he has made is final, since all calculations depend on the validity of the data, and no authority is unshakable in science, because no man can possess omniscience. It was Lord Kelvin who, but a few years before the thing was actually accomplished, declared that aerial navigation was an impracticable dream, and demonstrated its impracticability by calculation. However the connection may be brought about, it is as certain the evidence can make it that solar outbursts are coincident with terrestrial magnetic disturbances, and coincident in such a way as to make the interference of a casual connection irresistible. The sun is only a little more than 100 times its own diameter away from Earth. Why then, with the subtle connection between them afforded by ether, which conveys to us the blinding solar light and life-sustaining solar heat, should it be so difficult to believe that the sun's enormous electric energies find a way to us also? No doubt the impulse coming from the sun acts upon the earth after the manner of which a touch upon a trigger, releasing energies which are already stored up in our planet. But besides the evidence afforded by such occurrences that have been related of an intimate connection between the solar outbreaks and terrestrial magnetic flurries, attended by magnificent auroral displays, there is another line of proof pointing in the same direction. Thus it is known that the sunspots period, as remarked in a preceding chapter, coincides in a most remarkable manner with the periodic fluctuations in the magnetic state of the earth. Coincidence runs into the most astonishing details. For instance, when the sunspot period shortens, the auroral period shortens to precisely the same extent. As the short sunspot periods usually bring the most intense outbreaks of solar activity, so the corresponding short auroral periods are attended by the most violent magnetic storms. A secular period of about 222 years affecting sunspots is said to have its auroral duplicate, a shorter period of 55.5 years, which some observers believe that they have discovered appears to be common to the two phenomena, and yet another superposed period of about 35 years, which some investigators aver exists, affects sunspots and aurora alike. In short, the coincidences are so numerous and significant that one would have to throw the doctrine of probability to the winds in order to be able to reject the conclusion to which they so plainly lead. But still the question recurs: how is the influence transmitted? Here Arrhenius comes once more with his hypothesis of negative corpuscles, or ions, driven away from the sun by light pressure. A hypothesis which seems to explain so many things, offers it also as an explanation of the way in which the sun creates the aurora. He would give the aurora the same lineage with the zodiacal light. To understand the application of this theory, we must first recall the fact that the earth is a great magnet having its two opposite poles of magnetism, one near the Arctic and one near the Antarctic Circle. Like all magnets, the earth is surrounded with lines of force, which, after a manner of the curved rays we saw in the photograph of a solar eclipse, start from the pole, rising at first nearly vertically, then bend gradually over, passing high above the equator, and is so placed in space that it lies nearly at right angle to the direction of the sun, and as the streams of negatively charged particles come pouring in from the sun, they arrive in the greatest numbers over the earth's equatorial regions. There they encounter the lines of magnetic force at the place where the latter have their greatest elevation above the earth, and where their direction is nearly horizontal to the earth's surface. Obeying a law which has been demonstrated in the laboratory, the particles then follow the lines of force towards the poles. Where they are above the equatorial regions, they do not become luminescent, because at the great elevation that they are there occupy is virtually no atmosphere. But as they pass on towards the north and the south, they begin to descend with the lines of force, curving down to meet at the poles, and encountering a part of the atmosphere comparable in density with what remains in an exhausted Crookes tube. They produce a glow of cathode rays. This glow is conceived to represent the aurora, which may consequently be likened to a gigantic exhibition of vacuum tube lights. Anybody who recalls his student days in the college laboratory, and who has witnessed a display of northern lights, will at once recognize the resemblance between them in colors, forms, and behavior. This resemblance had often noted before Arrhenius elaborated his hypothesis. Without intending to treat his interesting theory as more than a possible correct explanation of the phenomena of the aurora, we may call attention to some apparently confirmatory facts. One of the most striking of these relates to a seasonal variation in the average number of aurora. It has been observed that there are more in March and September than at any other time of the year, and fewer in June and December. Moreover, and this has a delicate test as applied to the theory, they are slightly rarer in June than in December. Now all these facts seem to find a ready explanation in the hypothesis of Arrhenius. Thus, 1. Particles issuing from the sun are supposed to come principally from the regions whose excitement is indicated by the presence of sunspots, which accords with Hale's observations that sunspots are columns of ionized vapors, and that these regions have a definite location on either side of the solar equator, seldom approaching it nearer than within 5 degrees or 10 degrees north and south, and never extending much beyond 35 degrees towards either pole. 2. The equator of the sun is inclined at about 7 degrees to the plane of the earth's orbit, from which it results that twice in a year, in June and December, the earth is directly over the solar equator, and twice a year, in March and September, when it is farthest north or south from the solar equator, it is over the inner edge of the sunspot belts. Since the corpuscles must be supposed to be propelled radially from the sun, few will reach the earth when the latter is over the solar equator in June and December, but when it is over, or nearly over, the spot belts in March and September, it will be in line of fire of the more active parts of the solar surface, and relatively rich streams of particles will react it. This, as will be seen from what has been said above, is in strict accord with the observed variations in the frequency of aurora. Even the fact that somewhat fewer aurora are seen in June than in December also finds its explanation in the known fact that the earth is about 3 million miles nearer in the sun in the winter than in the summer, and the number of particles reaching it will vary, like the intensity of light, inversely as the square of distance. These coincidences are certainly very striking, and they have a cumulative force. If we accept the theory, it would appear that we ought to congratulate ourselves that the inclination of the sun's equator is so slight, for as things stand, the earth is never directly over the most active regions of the sunspots, and consequently never suffers from the maximum bombardment of charged particles of which the sun is capable. Incessant auroral displays, with the undulating draperies, flitting colors, and marching columns, might not be objectionable from the point of view of picturesqueness, but one magnetic storm of extreme intensity, followed closely by the heels of another, for months on end, crazing the magnetic needle, and continually putting the telegraph and cable lines out of commission, to say nothing of their effect upon wireless telegraphy, would hardly add to the charms of terrestrial existence. One or two other curious points in connection with Arrhenius' hypothesis may be mentioned. First, the number of aurora, according to his explanation, ought to be greatest in the daytime, when the face of the earth on the sunward side is directly exposed to the atomic bombardment. Of course, visual observation can give us no information about this, since the light of the aurora is never sufficiently intense to be visible in the presence of daylight. But the records of the magnetic observatories can be, and have been, appealed to for information, and they indicate that the facts actually accord with the theory. Behind the veil of sunlight in the middle of the afternoon, there is good reason to believe auroral expeditions often take place, which would eclipse in magnificence those seen at night if we could only behold them. Observation shows, too, that aurora are more frequently before than after midnight, which is just what we should expect if they originate in the way that Arrhenius supposes. Second, the theory offers an explanation for the alleged fact that the formation of clouds in the upper air is more frequent in years when aurora are most abundant, because clouds are the result of condensation of moisture upon floating articles in the atmosphere. In an absolutely dustless atmosphere there would be no clouds, and it has been proved that negative ions, like those supposed to come from the sun, play a master part in the phenomena of cloud formation. Yet another singular fact, almost mystical in its suggestions, may be mentioned. It seems that the dance of the auroral lights occurs most frequently during the absence of the moon from the hemisphere in which they appear, and that they flee, in greater part, to the opposite hemisphere when the moon's revolution in an orbit, considerably inclined to the earth's equator, brings her into that where they have been performing. Arrhenius himself discovered this curious relation of auroral frequency to the position of the moon, north or south of the equator, and he explains it in this way. The moon, like the earth, is exposed to the influx of the ions from the sun, but having no atmosphere, or almost none, to interfere with them, they descend directly upon her surface and charge her with an electric negative potential to a very high degree. In consequence of this, she affects the electric state of the upper parts of the earth's atmosphere, where they lie most directly beneath her, and thus prevents to a large extent the negative discharges to which the appearance of the aurora is due. And so the extravagant and erring spirit of the aurora avoids the moon as Hamlet's ghost fled at the voice of the cock, announcing the wakening of the good of the day. There are even other apparent confirmations of the hypothesis, but we need not go into them. We shall, however, find one more application of it in the next chapter, for it appears to be a cure-all for the astronomical troubles. At any rate, it offers a conceivable solution of the question, how does the sun manage to transmit its electric influence to the earth? And this solution is so grandiose in conception, and so novel in the mental pictures that it offers, that its acceptance would not in the least detract from the impression that the aurora makes upon the imagination. End Chapter 9. Greg Bell, Katy, Texas.